G'day everybody, hope everyone's well. So we're continuing on with the BMW build in this video. So if you watched the previous video, which was me engineering together the engine mounts for this swap, I hinted to the fact that I needed to manufacture and design a shifter extension to work with this swap as well, which is going to be what we're covering in this video. So the gearbox that I'm using for this build is the Toyota R150 gearbox. So there's a bit of Toyota gearbox lore that we need to discuss before we get into me manufacturing this extension, because Toyota actually did have their own extension setup, which they fitted to a couple of cars. I believe it was the JZX100. But we're just going to touch on the 3RZ, which is obviously the engine I'm swapping here, the couple of gearboxes that Toyota fitted to it, OEM, and just a bit of history and discuss why I chose the R-Series gearbox. So let's get straight into things. Now, something we have to clear up before anything is the fact that this isn't actually a Toyota manufactured gearbox. Yes, if you look at the VIN plate, you're going to see this is an R-Series gearbox, and there's a lot of other gearboxes that Toyota uses under different series names. However, the gearboxes themselves are manufactured by Aisin Corporation. This is a separate company that Toyota has part ownership or equity within. This is where most of Toyota and many other brands of vehicles gearboxes get made. It makes sense for a car manufacturer to get its gearboxes manufactured somewhere else rather than have to tool machine shops to just manufacture alone for them. It doesn't make sense. It's just a waste of money. So the Toyota gearbox here, the R150 that I'm going to be using, actually has very many similarities, if not a mirror image of the Aisin AR5. So the Aisin AR5 is pretty much a later manufacture of the R150. It shares pretty much all of its common similarities with the R154. The guts of the box is pretty much the exact same as all of the R-Series boxes. What it does have is an upgraded synchro on 5th gear in a clutch pack sort of system. And if we compare this to the R-Series boxes, on the left we've got one of the newer ones. It has the same style clutch pack system for the synchro, and on the right is the old style R-Series synchro for 5th gear. As well as that, you can see here the synchros are of different designs, the old style being on the right, and the ones on the right tend to wear out faster and cause dramas, so it's good to get the newer style boxes. The R155, which comes in the Toyota Tacomas these days, the two-wheel drive version, it shares pretty much every similarity with the AR5, as it's a newer manufactured box as well. So as you can see on the screen now, I've got a bit of information relevant for the R-Series boxes. They all pretty much are in a big giant group of incests between each other, being related to each other in ways of manufacturing. When they have manufacturing lines producing updates on designs, they'll often just roll it out halfway through a year. There won't be a sort of design change to the name. They'll just add this in, and this gets complicated when we're trying to talk about specific changes in design. So as I mentioned already, the box that I'm using here is an R150 from the Toyota Hilux TGN 16R. So this Hilux was manufactured between 2004 and 2015, I believe. The thing about this box we got to keep in mind is it's slightly undesirable as far as gear ratios go. So first gear on this box is really short. That's because it's designed for a pickup truck, so you know, if you're towing a trailer or you've got a bit of weight in the back, it's not going to bog down when you're getting going. So this R-Series gearbox just has the normal style shifter that mounts to the back of the rear housing of the gearbox. The R154 did come with an extended shifter, which is in a tripod setup, it's called. This is where the shifter pin itself is external to the gearbox through a sealed hole. There is also an integral or a fully sealed shifter extension style, which the W58 gearbox did use, and you can see here it's fully enclosed compared to the tripod style. So the next thing we had to do as far as the shifter extension went, had to mock the box up in the car and take every measurement humanly possible with as many photos as I could physically take, so that I was able to reference this when I was drawing up my design on the computer. This is because the box was going to have to be in the car for mock-up, and then it was going to have to come back out so I could take all of the measurements I needed of the shifter housing flange face itself. So there's a lot of critical dimensions here. We're going to talk about them a little later on, so you need to make sure your measurements are as exact as they possibly can be. So realistically, if you're taking on this task, you're going to need to know how to use all of your micrometers and verniers and all of your, special measurement devices that engineers and machinists are able to use. I take it if you don't know what a vernier is, you're not going to be doing this job. Don't get me wrong though, you don't have to be a brain surgeon to do this job. You could definitely engineer together your own system with tape measure. The thing is though, with any sort of design or iteration of a mechanical device that you put together yourself, there's going to be teething issues, and this is, welds cracking, or there being issues and defects with the design that don't really show themselves until down the line. My main concern was me designing something that's going to be a bit slapdash, it's not going to work correctly, and I'm going to have to pull a gearbox back out of the car to fix it down at the track. This is why I'm taking such an effort to do everything properly to start with. I guess in an ideal world I'd be using 3D CAD software like SolidWorks, where you can actually model the stresses and forces that are going to be going through the piece that you're designing. But, we're not going to necessarily need to do that, and realistically we don't have to do that for something as small as this. Because this piece is just going to be sort of transferring the torque that I'm going to be generating by my hand on the shifter through to the rear housing of the gearbox, we can make a confident assumption on how big or thick the metal has to be and what material we have to make it out of. So the program that I use for all of my CAD drawings is Wondershare eDraw Max. So this is a 2D program. I use it for all of my wiring diagram drawings and my pan ID drawings as well. It's really useful. I like this program because it utilizes both the X and the Y axes with grid references, and they scale it. So what this means is you can do scaled drawings, and it also has snap features, so you can draw things exactly as they need to be size-wise, and then you can scale it down. So here's what I came up with for my first batch of measurements. So this is all of the bolt holes of the shifter housing mating flange, and you can see I took the dimensions of the shifter trunnion cup, I guess you'd call it. Now this cup is critical in how high it sits compared to the shifter housing face. This is because the shifter itself is spring-loaded in the top housing, and this means that it's going to apply a certain amount of force pushing the end of the shifter stem and the shifter bushing into the shifter trunnion cup here. Now, would this cause a problem? Potentially not. If you look at how the shaft that the shifter trunnion cup's bolted to is mounted, that's pretty solid, and you'd have to be applying a stupid amount of force over a stupid amount of time to be, causing any significant visible wear there. I did end up keeping and using this top shifter housing here, so that's why I wanted to keep things as close to factory spec as possible. The last thing to note here is the fact that this whole shifter housing mating flange sits on a 4.5 degree slant compared to the output shaft of the gearbox, so that's something else we have to keep in mind. Next I had to draw up the shifter extension itself. So for my datum to calculate the actual extension length I was going to need, I based this off the back of the shifter fork actuator arm. Now because my plan was to create a shifter extension assembly that bolted to the top of the original mating flange, this flange, as I mentioned before, sat on a 4.5 degree slant. This would mean that the top shifter housing that I was going to retain was going to be further down the further back the shifter extension went. And because of all this, I needed to calculate the thickness of the material I was going to need. This was going to be a critical dimension, so that depending on how long the extension was, the shifter top housing with the shifter arm and lever in it itself was going to be the right height to sit into the shifter trunnion cup correctly. So that may have not made sense to everyone watching, but when you see me manufacture and get this system operating, you'll further understand what I'm trying to say. It's very hard to get across like an imaginary design or describe it correctly. It's better to manufacture it and visibly show you. So this here is the final dimensions for all of the bolt holes I needed. This drawing was originally one I sent to a water jet cutting company because I ideally wanted this whole piece punched out of 5/8 thick steel plate. But that was going to cost like $600, so I decided to make the frame itself out of square bar and then machine that to the right height so that the shifter would be shimmed up enough to fall correctly into the shifter trunnion, and then machine the bolt holes myself on the mill at work. So that's what we're going to see me getting busy with now. So this is the completed revision 1 design for my shifter extension. Now, I'm sure a lot of people watching this are going to have seen issues in their mind as to choices I've made with the design and the iteration of this build. I'm not too concerned about it. I'm fairly confident this is going to function well enough for a long enough time to where I can be sort of happy and get a good bit of service out of it. Again, as I mentioned before, designing things and getting them implemented for the first iteration or the first revision, you have to expect there to be issues with the design, teething issues they call it. Now, as this design sits, I have to pull the gearbox out to actually get the whole system off, and you do have to, remove the rear housing of the gearbox as you saw to get the shifter trunnion cup knuckle out. Now, it isn't that much of an issue providing, you know, I can get a good bit of service out of it, but the fact that I cut, welded and extended the shifter trunnion, there is a chance that weld will crack, and if that does come loose, the car's obviously not going to be drivable because I won't be able to shift it. So that's a bridge that I'll cross when I come to it. I have got a lot more access inside the car now. Half the reason I did the shifter extension is because the shifter hole is sitting really far back in the BMW due to there being all of the aircon and stuff, which I've actually pulled out now, which you'll see in the next video. For the rubber bellows that I used to seal it up, this is a steering boot. It's a universal steering boot. I chose one of these because, you know, they're used to sort of having grease or having, you know, hydrocarbon based oils inside it, and they're used to a similar temperature that the gearbox is going to be seeing. So that's about everything I did for this video. I'm probably going to have, you know, issues with this as I'm trying to fit the drive shaft, because as you can see it does hang down a bit because of that 4.5 degree slant. But I'll be able to get around this. I can either just move the carrier bearing, shim it down so that there's a more of an angle for the drive shaft, or I can just notch out the drive shaft or this here. I'm not too fussed. I'm pretty happy with this design. And yeah, we're going to wrap things up here. Hope everyone enjoyed it. Stay safe, and I'll see you all in the next video.